In the previous section, we established matrices as one of the tools we're going to use to solve linear equations. We also use matrices to do a bunch of other stuff. So we want to take a little bit of time here to get some definitions down. What do we mean by a matrix? And what different things we talk about matrix. We will also look at how to do arithmetic, add, subtract, multiply, and eventually divide. We'll actually save all of that for the next video. Here we're just going to look at some definitions. So here we go. What is a matrix? Well, a matrix is a rectangular array of numbers. Uh, Here, for instance, is an array that's got 4 things across by 3 things up and down. Actually, when we talk about the size, that's number 3 here, the size of a matrix is given by the number of rows and the number of columns. So this is 3 rows, 4 columns. Rows always go horizontally, columns go up and down. So 3 rows, 4 columns, we say this is 3 by 4. This one here has 1 row, 4 columns, so this is 1 by 4. This one here has 3 rows, 1 column, it's 3 by 1. Okay, so the size of a matrix. The actual numbers in the matrix are called the entries in the matrix. So entries is something we're defining here. These two matrices are kind of special in that they have only 1 row or 1 column. A matrix that has only 1 row we will call a row matrix. Likewise, a matrix that has only 1 column we call a column matrix. Now you'll notice in the book when you read this that they say a row vector or a column vector as well. Later on when we actually talk about vectors, which we haven't done yet, there's a lot of things that behave like vectors. In particular, matrices and vectors behave in very similar ways. So sometimes this thing right here, we want to think of it as a matrix. Sometimes we want to think of it as a vector. Well, for now, we're going to think of it as a matrix. So a row matrix, a column matrix. Now, two matrices we'll say are equal if, and now I'm going to pause and go back and say, I don't want to talk about this yet. I want to talk a little bit more about the notation that we use. When we're dealing with a matrix that's non-specific, that you might know exactly what these are and you put the numbers in, but here's just a general matrix. It's got 3 rows, 4 columns, but I haven't assigned any particular values. The notation that we quite often use looks like this. We use capitals to denote the whole matrix. We use lowercase letters for numbers. Now these have little subscripts, so I'm using the subscripts to tell you where I am in the matrix. The size is always given by rows and columns. The subscripts are always representing rows and columns. So for instance, this one here, A sub 2, 3. So this is the entry in matrix A in the second row, third column. Rows and columns, 2, 3. So second row, third column. Down here, this one right here, A3, 1. Third row, first column. So A3, 1 is the entry in the third row, first column. Sometimes we shorten all of this by just saying A equals, in parentheses, Aij, where we may know that I is running between 1 and 4, and J is running between 1 and 3. Sorry, I have that backwards, rows and columns. So the I is between 1 and 3 here, and J is between 1 and 4. So the different size matrices would have different limits on what I and J can be. But this is the way we notate it. So for instance, now when I come back here to say that two matrices are equal, here's my definition. Two matrices are equal if all the corresponding entries are equal. So I say that matrix A equals matrix B if Aij equals Bij for all I and J. Notice that the I and J here are the same as the I and J there. So this entry in column 1, 1 is going to be the same as this entry in position 1, 1. And likewise in position 3, 4, this will be the same as the entry in matrix B at position 3, 4. That the I here is the same as the I there, J. So corresponding entries are equal. Now, a matrix is called square if the number of rows is the same as the number of columns. For instance, this matrix here, I have 3 rows, 3 columns. That's a square matrix. And in a square matrix, the entries where the row number and the column number are the same, that set of entries, so A11, A22, A33, this is called the main diagonal. There's two diagonals on a matrix, on a square matrix, and the main one is that downward sloping one, where the row number and the column numbers are all the same. Okay. So there's some basic definitions. Now we'll move on in the next video to do some arithmetic.